Hello, this is another in my series of videos where I'm doing the 2025 challenge from Everybody Codes many months after it was released. Today we're going to be doing Quest 18, and after my hard-earned lesson last time with Quest 16 being so easy, even if Quest 18 is easy, which I'm not going to count on, I am just doing Quest 18. I am not going on to Quest 19. So let us start the timer that's sitting over there and open up Quest 18. Small group. Each plant has its own thickness and may have one or more branches. Branch can be free or connected to the main body of another plant. Each branch can provide the end. Connections are designed in such a way. The thickness. I see. So I think that okay, so at least in this example, all of the things are ordered already in a post order. Let me download, and I'm going to move this over, and then I'm going to I wanted to look at this. Okay. Okay. Okay, so we have plant number with thickness number. Plant line parser regex dot must compile thickness if line parser dot find string submatch scanner dot text if okay. Now, map string int branch to okay, then we do first branch parser dot find string submatch of if okay, so free branch strcon dot a to I of first one thick there thick. Incoming energy plus equals the so here parsed 2 thick parsed 3 plus equals plant energies of incoming source times thick. Okay, then if plant thickness incoming energy plant energies plant name equals okay, wait. If we have okay, so if it is equal to, if incoming energy is greater than or equal to the thickness, then plant energy is incoming energy. Plant energies, plant name, plant energies, plant name. Okay, and yes, I did move it over, so now I just say go run quest 18. That's a lot. Yay, okay, but still almost 15 minutes to do part 1, even though it was straightforward and I got the answer right away. So if it's slightly different from your calculations. Red glow with a negative thickness value. Test cases in addition to the schema. Each test case is 0, means the corresponding for Okay, so with this I will have to actually record somehow. Okay. So what I'm going to do if okay, now for each plant okay, and now I want to do I want to just parse this into some kind of instructions? Parse this into a little computer. What kind of structure do I want to hold this data? Okay, type actually, what do I want? I want plant energies, test, and then it just okay. Instead, I'm just going to do this. Func that takes a type plant action is a function that takes a map like that, and a map int bool, right, we only ever have ones and zeros, yes. Okay, plant action, func takes that. Okay, actions, make, plant action, 0. Okay. Okay, so what we're going to see here, okay, we have thickness and we have right. So this is just going to add to the plant's energy. So act var plant action colon equals takes a plant energies, just say map from string to int test cases, which is a map from int bool. What we do here is we say if input number my desk name my input number, my desk name, anything else I'm going to close over. Yeah, my input number, my desk name. Okay, thick is that. If test cases bracket my input number plant energies bracket my desk name plus equals thick. so this is my desk name plus equals times thick. And then after this we do actions, append, action. Now we have to say actions, append, actions, if prioritize plant name is plant energy's plant name. Okay, that's the incoming energy. Less than plant thickness. Okay. Now, sum. Now I do strings dot split okay, what do we have here? We have that. Scanner.text. My test cases make, oh wait, here we do make map int bool test case for range vals test cases idx equals b equals 1. Okay, then for actions, act, plant entities, test cases, range, sum plus equals, plant entities, plant name. I think that works. Now I have to remember to download the data and move it over and say that I'm doing part 2. Okay, line 113. Okay. Okay, so I've screwed up something about my parsing. Aha, yes. Thickness minus question mark minus question mark. Okay, I forgot that thickness could be negative. Come on. Yay! Okay, that took way too long to verify. Meanwhile, okay, very free branches there. Looks like the mask for the dragon ducks. That's odd grammar. You decide to final plant in the system at all. Okay, so we find the maximum. We compare everything with the maximum, and we take the below max, ignoring the ones that are at 0. So for part 3, I think I will parse it exactly the same. Okay. Refactor. Extract function. Yeah, actually, actions and plant name. Okay, and new function, rename that to parse actions. Okay, so I parse the actions and then found values make map from int to int. Let's have sum not be equal to 0, and then let's just say sig here. Now okay. Okay, so I'm gonna do, yeah. Sig colon equals 0. Sig if v equals 1. Sig plus equals 1 idx. Okay, and in inputs, max okay, then for this what I'm going to do is I'm going to so for test gen max for test gen range one less than one shifted left n inputs. Bad name for that. Yeah, I'll have to rename test cases at some point. Then okay. If skip val found values at sig, okay, max last one, max last. Continue. Okay, test cases for IDX range and inputs. Test cases IDX equals ampersand sig max left. Okay, and now sum colon equals 0. Return sum for sum plus equals okay, this is enough that I'm going to, yes, I mean, sure, I will get that, and move it, and, okay, sure, maybe I'll, why not? Okay, well, that is obviously very, very wrong. Um, okay, so it did in fact exceed a signed integer. That's kind of surprising. Nope. Nope. Okay. So let's go back to this. Let's go back and get the. Let's go back and get the example case. Okay. And input everybody codes quiz 18 part 3. Okay, that says 946, and this also says 946. Interesting. But that says that, which is apparently just wrong. So, okay. Okay, so these are a lot of, and I'm kind of surprised that it was able to run all of these that fast. So I don't trust that it was able to run those that fast. So I'm going to there's no way it ran two to the 81 different inputs. Like, it couldn't have. This, one left 81, that must have just rolled around to 0, so it just, test gen was just 0, straight up. Okay, so what needs to happen is that so for plants 82 and up, do we ever have a negative coming from something with 82 or higher. Okay, we do not ever have a negative coming from anything that is 82 or higher. So, the only question we have is positive or negative on inputs that have a negative thickness attached to them. Okay, so unfortunately our parse program is going to have to return also more information for us. Is it? What if I just take all of my samples and I say, hey, for each sample, can I turn stuff on and off? Okay, so for scanner.scan, actions, plant name, inputs, map, make, map from int to, okay, so we can either have inputs that are always negative, always positive, or a mix, or nothing. Int zero, nothing, 1, always positive, 2, always negative, 3, both. Okay, and now here we have input characters, bracket, my input number, if thick greater than 0. One is always positive, or equals 1. If thick less than 0, input characters, my input number, or equals 2. Okay, and now plant energies, here, Now, okay, so now what I have to do is I have to find the things that always say so also okay. Now, okay, this is just to see if I need to do the hard thing. Oh. Plant 1. God damn it. Plant names, bracket, my dest name equals my input number. Okay, input characters of okay, so there is one that is 3. Okay, so okay, so first let's have test test cases for IDX range for actually ID input x equals val question val and so if it's not so for val equals 1, this will be true. For val equals 2 or 3, this will be false. Then for that, then what we do is we find the rightmost 3 and we flip it. Okay, we have the rightmost flip 3 that is 0. For up IDX range n inputs, if input characters bracket up IDX keep going. And test cases up IDX 0. Then test cases bracket equals true for down IDX if input characters down IDX equals 3, test cases down IDX equals false. Break. Okay, and now this goes away. $9.46, is that the right answer? Yes. Okay. No! Damn. I'm really close this time, though. I think. Okay, so let's forget about this UNT64 thing. And here, let's do found found values bracket sig. Okay, sig last plant name break. Okay. T.print line found 2 plant energies last plant name. Okay. So sig. Okay, 15080. Okay, why? Okay, wait a second. How is... Oh. I bet I'm collapsing some stuff from SIG. I bet I'm collapsing some stuff from SIG. Yeah, okay, so found values. Instead of found values being that, let's just say found values is an array of ints like 0 and what we are going to do is we are going to do found values append found values plant energies last plant name. Sig we can't use. Right, this is just too large to ever use there. Copy, paste, paste. Okay. Yeah, okay. Right, so the thing that was screwing me up there at the end was that I was still holding on to the idea that I could make up a signature out of by taking the inputs and treating them as one long binary number. But when the binary number is 81 digits long, you can't really do that, and you wind up, yeah. So instead, you just need to have found values be an array. And then for this, yeah, we do that. So I'll admit, I am not particularly happy about a shortcut that we took here, where we assumed that all inputs, that we could just take from each input and just look at how that input is used once, and from that determine whether this input is one that we always want off or always want on, or sometimes want off and sometimes want on. But as it turns out, we can do that. And these problems are, I mean, specifically the input is part of the problem. So if the input doesn't cover everything, you don't have to cover it. Okay. Well, I certainly would not be doing a second quest today for this video. Thank you for watching. I don't know when I will be able to get to the last 2 quests for the 2025 challenge. It would be kind of nice if I could do them on June 19th and June 20th. Today is June 18th that I did here quest 18. We'll see. I don't know. Thank you for watching. Check out my playlists here of everything I've done for all of the Everybody Codes problems and for the 2025 challenge in particular. Thank you for watching.